Hi there, in this video we're learning about how to name simple acids. If you want to learn some more chemistry, go ahead and click subscribe. My name is Jeremy Krug, and I have dozens and dozens, actually hundreds of chemistry videos here that you can use to learn more chemistry, whether it's high school chemistry, college general chemistry, AP chemistry. This is the place. Well, when we talk about acids, let's just look at a few symbols of acids. As you see what we have here, you'll notice that all three of these acids that I have on the screen have something very fundamental in common. Notice that they all start with hydrogen. And so one thing that you'll find is every acid, every simple inorganic acid that you're going to work with in first year general chemistry is going to start with hydrogen. Now, it was a Swedish chemist by the name of Svante Arrhenius, who, back in the 1880s first talked about acids and, what acids are, and first noticed that all acids are going to produce these hydrogen ions when they're dissolved in water. So when you're looking for acids, look for that hydrogen ion at the beginning of the acids. Now there's something else that all three of these particular acids have in common. I want you to notice the anion. So focus on the Cl part of it and the F and the Cn part of it. You'll notice that all three of those ions have names with the suffix IDE at the end of it. So Cl is chloride, the F minus ion is fluoride, Cn negative is the cyanide ion. Now, when we have acids that start with hydrogen and end with an anion that ends with IDE, what we do is we take off that IDE, we put ic on the end of it, and we place hydro on the front. So that means that HCl becomes hydrochloric acid. And you may have heard of that acid before. It's actually quite common. It's found in your stomach. It's stomach acid. It's also used in construction. It's sometimes called muriatic acid. It's the same thing. It's hydrochloric acid. HF, the F is the fluoride, that becomes hydrofluoric acid. And so hydrofluoric acid is it's a very important acid used by artists because it's used for glass etching. It eats through glass, and so it has to be stored in plastic. It's also very toxic to people. HCN, you got the cyanide at the end, that becomes hydrocyanic acid. In its gaseous form, it's sometimes called cyanide gas. Very, very poisonous, and you've probably heard of that compound before. Now let's take a look at some more acids. Let's look at these three acids here, and you'll notice that these are acids. Of course, they start with hydrogen. They have the hydrogen there on them. But I want you to notice that they have something else in common as well. All three of these acids have oxygen in them. And so you'll find that a lot of acids that we deal with in chemistry have oxygen. These are called oxyacids, and basically that just means that they're acids that have oxygen at the end of the formula. Now there's something else that these three acids have in common as well. If we focus on the anion, so just focus on that NO3 and the ClO3 and the PO4, those are all anions that have suffixes that end with ate. So in the last examples we had ide, here we have ate. And so the way this works is you'll just drop the ate, the ATE, and you'll replace it with ic. So in this case the H and then the NO3 nitrate becomes nitric acid. And ClO3 is chlorate, so HClO3 would be chloric acid. And PO4 is the phosphate ion, so we call that phosphoric acid. Now for some reason, acids that have phosphorus and sulfur in them add that extra little syllable in there just to make it sound a little bit less awkward. So instead of calling it phosphic, we call it phosphoric acid. By the way, that's a fairly important acid because it is found in several sodas. It's actually found in Coca-Cola, just as an example. If you look at a can of Coca-Cola, you'll find that one of the ingredients is phosphoric acid. It's right on there. So it is found in that very common beverage. Now notice, no hydro on the front of these. It's just ic. Let's take a look at 3 more acids. Once again, you'll notice that these are all acids. They have the hydrogen sitting on the front of them, and they're all oxyacids as well because they have the oxygen on the end. But I want you to notice at the anions that they have that we have on these this time, the NO2 and the ClO and the SO3, those are all anions with suffixes ending in -ite. So NO2 is called nitrite, and ClO is the hypochlorite ion, and SO3 is called sulfite. So the way this works is we drop the ite, and this time we replace it with us, O-U-S. And so HNO2, it's derived from nitrite, that becomes nitrous acid. And ClO is hypochlorite, so its acid form is hypochlorous acid. And SO3 is sulfite, so its acid form is not sulfus. Remember, it adds that extra syllable. Sulfur and phosphorus containing acids do this. Sulfurous acid. Fairly important acid out there in environmental science, environmental studies, because sulfurous acid is one of the components that's found in acid rain. Perhaps you've heard of that before. When sulfur, for example, found in certain types of coal, is burned, you burn it with O2, you get SO2, and then SO2 is a gas, and it reacts with water in the upper atmosphere and can produce this H2SO3. So we can call it sulfurous acid, and so that's a fairly important acid in environmental studies. Well, let's see if we can go in the opposite direction. Let's see if we can take a name of an acid and write a formula, because that's a pretty important skill to be able to do as well in general chemistry. So let's take this one, chlorous acid. Well, we know that since it's an acid, it has to have a hydrogen on the front of it, doesn't it? And hydrogen has a charge of +1. And then the chlorous, this suffix us, implies that the anion ends with ite. So we're talking about the chlorite ion. So chlorite has this formula, ClO2, and its charge is -1. So +1 and -1 cancel out, and so we don't have to swap the charges, and so the formula is just HClO2 whenever you scoot these together. So that's how you write the formula of an acid. Let's try this one, oxalic acid. So once again, since it's an acid, we know it is going to have hydrogen in it, and hydrogen has a charge of +1, and the ic, oxalic acid, implies that the anion ends with 8. So this is derived from the oxalate ion. So oxalate is C2O4. That has a charge of -2. Now I want you to notice that these charges do not cancel out. So as a result, we have to swap the charges. So when we scoot these together, it's going to become H2C2O4. And so that's the formula for oxalic acid, which is found in a few types of antifreeze. So in review, this is how we name acids. If the anion has a name that ends with "ide," then we put "ic" on the end and we put hydro on the front of it. If it ends with "ate," we change that ending "ate" to "ic." And if it ends with "ite," we change the ending to "us," O-U-S. I hope you learned something about acids. If you learned something, please hit that like button and subscribe to my channel. My name is Jeremy Krug, and I hope to see you again on my channel where we can learn some more chemistry together.